Well, good morning, good afternoon, or good evening, and welcome to today's DevOps.com webinar, brought to you by Techstrong and SiteCode. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation for you today. First, I have a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, and that's where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's program, or maybe just let us know from where you're tuning in. We do have a couple of resources available for you in the handouts tab, so feel free to check those out. And before we close out, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is effectively tackling hard-coded secrets with a secrets management maturity model. And I'm joined by Orion Cassetto, Senior Director of Product Marketing at SiteCode, and Julie Peterson, Senior Product Marketing Manager at SiteCode. Julie, Orion, thank you both so much for joining me. I'm going to let you take it away from here.
Thanks, Cody. All right, so we'll go ahead and kick things off. Real quick about us. So Cody mentioned, my name is Orion, I'm Director of Product Marketing at SiteCode. Got about 15 years in cybersecurity, much of that in application security, and very relevant to today's topic. Some of my past employers include Imperva, Exabeam, Distill Networks, and other than that, I'm a frequent speaker at security conferences and security nerd, so I'm definitely enthused about today's subject. Julie, what about yourself?
Well, I am Julie. This is true, and I am a senior product marketing manager here at SiteCode. I have been working in tech for longer than I care to admit, and I've been writing about a lot of different things, security, big data, and more. My work has been published in things like Forbes, D-Zone, Security Boulevard, and a lot of other publications, and I've in the past worked for companies that you may be familiar with, like IDC, IBM, and White Source Software, now called Mend.
Cool. So today's session agenda, Julie's going to tell us a little bit about hard-coded secrets just to set the foundation for our discussion. We'll talk about some major secrets-related incidents that have been in the news, and as we go through those, we'll call out some takeaways that we can think about as we move into effectively managing secrets using a maturity model. Here, our goal is essentially to give you a framework to understand how your secrets management program is doing and give you some actionable steps to move it forward into a more mature state. After that, we will talk about what solutions, what capabilities a solution might need to facilitate such a program. So, if you wanted to get to the highest level of maturity, what do you actually need, and what is your tool? What tooling, what capabilities does your tooling need? After that, we will go through a Q&A. So as Cody said, there's a Q&A box that you can use to, along the way, if you have questions, throw them in there. And when we get to the Q&A section, we will call out as many of them as we have time for. So with that said, why don't we kick things off? Julie, do you want to give us an overview of hard-coded secrets?
Yeah, sure. So, we're just going to sort of level set so we all know that we're talking about the same thing. But basically, a secret in code is, a digital credential, sometimes called an embedded secret. And most of them have to do with authentication. So think like username and passwords, authentication tokens. We're seeing API keys, database credentials, things like that. It also includes encryption certificates and encryption keys. And then there is sort of like a whole range of custom secrets. It could be something like an ID number, which on its own isn't a big deal. But when you combine it with insider information, it could maybe lead to like a customer data, or you can correlate it and find some proprietary stuff that you don't want to have out there. Custom secrets can also include things like activation codes or discount codes. So those are really common in the retail space. Again, you don't want somebody to be able to activate a service for your gaming platform, every year for free. So again, you want to keep those under wraps. And then more and more, we're seeing GitHub used as kind of like a Dropbox service. And so developers are storing non-code in their Git accounts. And so you have to be aware of what those kind of things might contain and whether it contains any sensitive information. So, we are seeing an increase in secrets. And the main reason for that is that the way in which we have the way in which we develop code has changed recently. So we've moved really into this sort of SaaS and third-party services, which all require additional authentication needs. In addition, right, we're chunking down our code into smaller and smaller bits, right? Our microservices architectures, when you're talking about containers, they all need to speak to each other, which again is increasing the need for authentication. And then things like infrastructure as code. Again, you have to, you're logging in your infrastructure, might need to call into a database to get it set up. Again, more and more authentication is needed across the board. Secrets are a problem for a number of reasons. The first one really is about lateral movement. And what we're seeing is that attackers can infiltrate your pipeline pretty much at any point. And then they can hunt around for these hard-coded secrets and then find legitimate credentials where they can then log in to different accounts or different applications. And what we're seeing here is that developers are spending much more time in your systems when they're attacking you, and then they're actually able to move, left into your source code. They're able to move right into your production applications and just do a lot more damage than before. Secrets are also a problem for some compliance issues. So if you look at something like Sarbanes-Oxley, right, separation of duties is a really huge component there. And if you have a developer who can find the credentials to log into, say, a database, if they could get into a database, but yet they're not a database administrator, then that is really a clear separation of duty. Now, the reality is for things like SOC 2 and ISO 27001, we're not seeing a ton of auditors asking these questions at the moment, but we do expect that going forward that more and more questions about separation of duties will be on the plate, and you'll need to answer for them. And then finally, we're seeing that exposure is just becoming more and more common. So attackers are specifically going after developers' accounts because they're really well provisioned and they have access to all of these secrets. So think about the Sawfish attacks from 2020, right? It was a really sophisticated phishing attack specifically targeting developers and their accounts. We're also seeing a lot of accidental leaks in which a hard-coded secret might be exposed. So something like the way Git systems are designed, developers bring their own account to their organization. And it is very easy to accidentally save proprietary code to their personal account, which is set to public, because they're sharing their personal information or their personal work. And so all of a sudden you have a ton of code exposed and potentially hard-coded secrets exposed. And then again, you always have to worry about malicious insiders. We're seeing with the Great Resignation over the last couple of years that developers are, 3 times as likely to leave their job. And we're also seeing that, often they're copying and taking some of the code with them. So again, it is a big problem, and it's still persisting because, even though we know it is a problem, it requires a change in user behavior. And as we all know, change is hard. And then finally, this last section here shows GitHub's Digital Millennium Copyright Act takedown notices. And as you can see, there's a clear trend that they're increasing exponentially. So I think, if you look back to 2015, there were less than 150 takedown notices that year. If you look up to last year, there were over 2,000. And these notices aren't a one-for-one. So one notice can, request that tens of thousands of repos be taken down. So what this is showing that a clear trend that, your code is being leaked, or it is likely to be leaked more and more than ever before. So, when we hard code a secret, we're assuming that only the right people, only the trusted people are going to be able to see that secret. But the reality is that you have to assume at some point your code is likely to be leaked. And if you have secrets in code, they're going to be exposed when your code is leaked. So you just can't assume that only insiders have access to it. So, we're telling you that it's bad, but let's look at some specific examples to really kind of drive home how concerning secrets are and how valuable they are. I just lost an earbud, but I'm back. So, the first incident I want to talk about is SolarWinds. We all know it was a really sophisticated attack by a nation state. If somebody like that is going to go after you, you're going to be hard pressed to, prevent it. But what we know about SolarWinds is that it was a Team City attack, that there was, but we also feel that there were secrets leaked in the FTP server, via an FTP server. And we believe that the evidence is showing that because SolarWinds was so thoroughly and comprehensively infiltrated, and that the attackers were there for so long, that it is believed that secrets played a really large role in expanding the attack surface. Now, if you look downstream at SolarWinds customers to Microsoft, who was one of the companies were impacted, one of the things that Microsoft found post-mortem was that the hackers were specifically looking for hard-coded secrets. Now, Microsoft told us that they didn't actually have any hard-coded secrets in their code, so great for them. But they could tell that the attackers were specifically going after those secrets, which just shows you how valuable they are. I think, Orion, you have another example.
I do, yeah. This example comes to us by way of the Office of IT from New York State. Essentially, what this was a code leakage. So a bunch of proprietary information was leaked, including some proprietary projects and hard-coded secrets and whatnot. This all happened because the New York State Office of IT's GitLab instance was misconfigured. So essentially, anyone from the public internet could go to their GitLab account to create an account, assign themselves admin privileges, and then access all of the information in the repos, some of which were production and some of which contained hard-coded secrets. And I guess there are some takeaways here, chief of which is that, it is easy to have your code exposed. It can happen by things that are not directly related to coding practices. In this case, misconfiguration of the SCM. But, the most important time to know if you have hard-coded secrets in your code is when it gets exposed. So, essentially, it goes right back to what Julie said earlier. You can't assume that your code won't be exposed, because frankly, it happens all the time and it's quite easy to do.
Yeah, that one still blows my mind. And another example of one breach that with secrets all around is KODAK. And here secrets played like a fundamental role in the beginning, middle, and end. So KODAK had a Docker image with a secret in it, and the attacker found it and used that to log into KODAK systems. And then what they did was they actually changed the bash uploader script to get stolen credentials. So they had that bash uploader script was sent to downstream customers, and what happened was the downstream customers, when they installed it, all of a sudden they're sending their Git credentials instead of back to KODAK, they were sending it to the attacker server. So the attackers took those stolen credentials and then used it to log into their systems. And so companies like Twilio, HashiCorp, Monday, and a lot of other great development shops were infiltrated that way. And then when the attackers got into these downstream customer systems, what were they looking for? You guessed it, they were looking for secrets. So again, beginning, middle, and end, all around, secrets were the main point of this attack. And it just shows you how valuable they really are.
Yeah, that one's
got one more? Yeah.
Got one more.
Got one more for us? Yeah. Good.
Yep, this one comes to us by way of Amazon. So essentially what happened here was there was an inadvertent data leak from Amazon. It included just a ton of information. So like a gig of information that included, kind of personal files from an Amazon Web Services engineer, but it also included essentially secrets that gained access or provided access to Amazon Web Services resources. There are two takeaways from this one. One, if it can happen to Amazon, it can happen to everybody. Amazon's typically, does a fairly good job, with security, and they're kind of at the forefront of cloud technology. The second and more probably important takeaway from this specific instance is that the time from the leak occurring until essentially the public notified Amazon that they had this leak and that it involved secrets was measured in minutes, just a couple of minutes. And I mean, the good of it is that the people who discovered it in this case were benevolent. They were seeking to help Amazon rectify the issue, but it could have just as easily been an attacker. And the takeaway for you and the takeaway for essentially our maturity model as we move forward is these things happen very quickly and they need to be dealt with very quickly, because a matter of minutes can be the difference between a secret that's exposed turning into a breach and not. So with that said, we are going to launch our first poll before we start talking about our secrets management model. So it's just popped up right now. We'll give you some time to answer it. The question is, what causes you to lose the most sleep about hard-coded secrets? Is it exposure via source code leaks like we just talked about? Is it exacerbating existing attacks like we saw with a bunch of those attacks, but KODAK? Is it compromised insider accounts, malicious insiders, or as Julie referred to earlier, ideally or potentially a compliance violation? So why don't everybody go ahead and answer that question, and we'll see what the results are. So the results are coming in now. Give you another 30 or so seconds. Looks like right now our front runners are exposure via source code leaks and compromised insider accounts and the fear of compliance violations. So we've got our results. Number one is exposure via source code leaks. Number two is compliance violations. And number three is insider accounts. Very interesting. All right. With that said, we'll keep moving forward. And our next topic in the presentation is how to effectively manage secrets using a maturity model. So here's what the model looks like at kind of an aggregate level or at a high level. What we've done is we've assembled 5 levels of maturity, from the least mature being awareness to the most mature being risk reduction. The goal here is to describe what each level looks like, what are its characteristics, and how do you get to the next level. And then ideally, again, you should be able to identify your security program's capabilities somewhere in this model. And then from then on, you'll have some actionable steps as how to get to the next model, or the next level in the model. Pardon me. Okay, so the first level is awareness. This is the most basic level. Here, by virtue of you being here, you probably are already in this level, or if not higher. What this is all about is understanding that secrets are increasing due to how we're coding applications, understanding that you may be at risk of having hard-coded secrets in your code base, and then trying to do something about that, which typically starts with developer training and establishing some very basic policies you can use to start to handle the problem of hard-coded secrets. What it does not include at this point is any form of secret detection other than kind of manual discovery. So no scanning, no tooling, and no enforcement mechanisms, right? So right now, you're very much in your nascency. Let me give you an example. I talked to one organization that essentially is representative of someone who is at level 1, and their way to deal with hard-coded secrets was to fine developers $50 if their code, when it was merged, included a hard-coded secret. Now, there's a whole bunch of things wrong with that. One, it doesn't stop the secret from reaching your code base. 2, it doesn't have any ability to find them elsewhere in your SDLC. It doesn't look in past version histories. It's essentially a band-aid, right? There's nothing here. It doesn't scale. So Now, that's what a level 1 organization looks like. Okay, so taking it one step further, you get to a level 2 organization, which is basic detection. And here, what you're doing is starting to use tools to help you to scan your environment or your code for secrets. Very specifically for a level 2 organization, these efforts and these tools are focused, laser focused on your source control management systems. Ideally, almost exclusively, they are, focused primarily on your main branches and your most critical repos, but ideally you should be scanning everything. Many organizations at this level are starting to take into account version histories. The idea being, if you had a secret that's exposed in the past, you need to know about that too, because that secret is effectively burned, right? If it can be discovered. And so, you're going to need to change out that secret, even if it's no longer in your code base, but it was at one point in the past. Here, scans are looking for common secret formats. It's things like API keys, passwords, authentication tokens, database credentials, things of that nature. And these scans are being run on an ad hoc basis or a timed basis. They're not baked into a workflow, like we'll start to see later in more advanced models. Level 3 is advanced threat detection or advanced secrets detection. And here we're expanding on the concepts of level 2 in terms of breadth, depth, and fidelity. So breadth and depth, what I mean there is essentially looking for secrets in more places and looking for more types of secrets. Secrets are not just in your repos, right? They can be in version histories, like I said a second ago. They can also be throughout your entire SDLC, in places like build logs, container registries. They can be in public infrastructure. They can be in infrastructure as code. They can be in public repos. They can be in developers' repos. So really, you need to be thinking very, holistically about where you're pointing your scanning tools and efforts so that you can find them everywhere. Second thing is, if we go back to the very beginning of this presentation, when Julie was talking about, what secrets are, one of the things she said is that, there are custom secret types that are important for you to find as well. And so at level 3, you're going to start to look for custom secrets. And here it could be things like ID codes, it could be activation codes, it could be discount codes, it could be something that's completely specific to your application or your business logic, but you need to be able to find it and make sure it's not hard-coded into your code. The next thing that comes in at level 3 is the idea of prioritization. And here it's, if you have hundreds or thousands of secrets that have been uncovered, how do you determine which of those you should address first? So you can kind of point your remediation efforts at the most critical secrets. And here it's taking into account things like, is it in, test or production? What is the resource that it gains access to? Things of that nature. And we'll give you some tips on what that might look like and capabilities that you should be taking into account. But level 3 is where that starts to come in. Level 4 is about enforcement and alternatives. So essentially, now that we've got scanning in place and we've got fairly robust scanning, here what we want to do is to basically stop the practice of hard-coding secrets. And that comes in 2 ways. 1, we need enforcement of our policies so that we can stop the practice. And 2, if we're going to enforce those policies, we need to give an alternative to developers so that they can still do their job efficiently without hard-coding secrets. We'll talk about these separately. First, we'll start with enforcement. Here, one of the best tools you can use is essentially scanning for hard-coded secrets in developer workflows at the time that code is being committed or at the time that code is being merged into your main branch with a merge request or a pull request. So it's exactly what it sounds like. When that code's getting committed, you're going to look for hard-coded secrets. If you find them, you're going to alert the developer right then and there and say, look, you've got this hard-coded secret. Here's your remediation advice. Now, you can take that one step further at the pull request by actually blocking the pull request. Now, this is an optional step. Not everyone wants to be that iron-fisted, but the idea being if you block that pull request, if it has a secret in it, then you're essentially sanitizing your main branch. You're preventing a hard-coded secret from kind of tainting your main branch. And then if you do that, then again, you need to provide remediation guidance and assistance for your developer. Now, in order to increase adoption or adherence to this framework, to the idea of blocking a pull request or scanning within the developer workflow, it's important to provide your developers with an alternative, right? And that is where a secrets management tool comes in. Here, the idea is, very similar to the idea of a password manager or a PAM tool, privileged activity monitoring tool like a CyberArk. It's the idea that essentially, instead of hard coding your secret into your application, you're going to have your developers tell your application to reach out to the secrets manager whenever they need to authenticate or access a protected resource. That secrets manager is going to provide a secret that will provide the application access. And then, essentially, instead of having the request or the secret in code, you have the request to get a secret in your code. There are some benefits here. First and foremost, you don't have any clear text secrets in your code. So if the code gets leaked, it's not so much of a problem. 2, if you discover that you have secrets that have been burned, you can rotate them at the secrets manager. So, essentially, this is a very efficient way to handle secrets. And it's a very complementary solution to the idea of, scanning at time of scanning in developer workflows, because there you're preventing them from entering your code. And here you're providing the alternative. So these are kind of the 1-2 punch. The last and highest level is risk reduction. And this is something that, not a lot of organizations are achieving yet, but they should be striving to get to. And the idea here is that you want to look more holistically across your entire, SDLC and your security program and figure out what can we do to reduce the risk that secrets pose our organization other than just the secret itself. And how this works is risk is essentially made up of a threat and an exposure. The threat here being the secrets. Now, how do secrets get exposed? How do they become dangerous? That happens when you have code leaks that end up in the wild and attackers can get access to them. It happens when an attacker gains credentials to a developer account and then has access to the secrets that might be in the code base that developer can access. And they become dangerous when they fall into the hands of the wrong people, like a malicious insider. So if we can address kind of those exposure risks, and you can keep secrets from getting into attackers' hands and then reduce the overall threat they pose or the risk they pose to your organization. How do we do that? We'll talk about these separately, and we'll go through each of those buckets. The first bucket being compromised insiders. So the problem here, you've got attackers who are gaining access or stealing the credentials to your developers, and then they have access to all code that developer had access to. And then if it has hard-coded secrets in it, then you've got attackers plus secrets, and that's bad news. So there's a couple of things that you can do here. The first is make sure that you have strong authentication. Here, making, MFA is a perfect example. Making sure that your MFA is configured appropriately and rolled out uniformly across your tooling will help a lot. And what you're trying to do here is to make it harder for your developer accounts to be compromised. The next thing you can do is enforce the concept of least privilege. What least privilege is it's trimming down access to resources and to code to only the stuff that you need to do your day-to-day job. For example, in doing so, you essentially make it so an attacker has to compromise the right account that has access to the right code that actually has hard-coded secrets in it. So by trimming down that access privileges, you're reducing the overall risk threshold or risk. That same concept of least privilege is also useful for malicious insiders because you essentially have someone who is looking to abuse their access privileges by accessing code with hard-coded secrets in it. And if they have less code access, the chances of them having access to a repo they could abuse goes down. The last thing comes down to source code leakage. This was the #1 concern based on our poll. So things you can do here. There are tools. They're not part of typically a secret scanning tool, but they are kind of adjacent tools that can help you to do 2 things. The first is to essentially help to strengthen the configurations of the tooling that makes up your DevOps tools and infrastructure. That's your source control management tools, your build tools, etc. And to tune them in a way that makes it harder for accidental breaches to happen. That's the first thing, strengthening security and governance of your tooling. The second thing you can do is there are tools out there that will essentially scan your source code and your repos, fingerprint your source code, and then on a regular basis, go out to the public scanning sites out on the internet and to look for those fingerprints and to look for your proprietary source code. And if it finds it, alert you so that you can do something about it. And ideally here, what you want to do is to minimize the amount of time that your code is out in the outside world and take it down before an attacker can gain access to it. As we learned from Amazon, that can sometimes be in minutes. So, having something that's out there proactively scanning the outside world for you and notifying you makes a big, big difference. So essentially, if I had to summarize the idea of risk reduction, it's how do you holistically approach the idea of hard-coded secrets using other adjacent security techniques to reduce the risk of a breach from secrets? With that, we are going to move into our second poll, which will come up here in just a second. The poll question is, what is your organization's biggest unmet need for hard-coded secrets? The first one being basic secret detection. So essentially you have basic secret detection, or you have no secret detection, or you're just getting started. You're a level 1 organization. The second one being scanning for secrets everywhere in the SDLC. So not just in your SCM. So you have a problem with that. You have too many false positives or false negatives. You lack developer buy-in, or you have an overemphasis on finding secrets versus risk reduction. That's the idea that I just talked about. I'll give you some time to work through that one. Looks like we've still got some answers coming in, so give it a little bit more time. Yeah, these essentially correspond to the levels of the maturity model. All right, looks like we've got enough that we can start sharing our results. So, biggest unmet need for organizations. Number 1 is just, hey, we want to find basic secrets, or we don't have secrets detection, or we're just getting started. We hear that a lot. So, a lot of organizations are just figuring out what they need to be doing. Tied for second is the idea of essentially finding secrets across your entire SDLC and baking in secrets into your developer workflow. And number 3 is the idea of, having, inaccurate results. So either high false positives or false negatives. All right, so we'll talk about what we can do about all of these vectors. Okay, so we're going to shift gears. So far we've talked about why secrets matter. We've talked about them in the news. We've talked about our model. And now we need to talk about what capabilities do you need from a tooling standpoint in order to make that maturity model work. So Julie, you want to start us off?
Yeah, I'd love to. Yeah, so how can you move from wherever you are, level 1 or 2, and move on to, level 4 or 5? So the first thing you need to do is scan. I know it sounds obvious, but you need to know what you have out there. And, we suggest that you use a tool that has a number of complementary approaches to detecting secrets. So, looking for known patterns, such as like a Google API key has the same pattern. So that's a great way to start. And, this is the most accurate approach. So if you know the pattern of your secret, you should have a tool that can search on it. The second thing is to look for high entry strings that might indicate that a secret is there. Now, that does have a high false positive rate. Again, it can uncover a lot of good information that you need to work on. And then finally, you need a tool that can scan for custom or something that's specific to use and how your application is built. Now, having all of these results is great, but you need to actually be able to improve them, right? Find out what's real and improve those results so that you can get rid of the false positives and ignore what you don't need. So enabling developers to easily do that is a really key part of the tool. And then finally, you need to be able to look at your scan results and correlate it to which DevOps stage, right? A secret that is in a test environment is inherently less risky than something that is in a production environment. And that is something you need to know so that you can prioritize your scanning results, which is a good segue into what Orion is going to talk about next.
Absolutely. So prioritization is our next topic. Capabilities here. First off, the problem we're trying to solve is that you may have hundreds or thousands of secrets that you discover across your environment. And so what essentially you need here is the ability to look across your entire SDLC, like Julie just said, and to take information from all of the different tools across all the different phases and to figure out, like, okay, based on this information, how do we prioritize? Now here, prerequisites, you need data kind of from everywhere, and a suggestion for how that data might be organized. Solutions that are built on top of a graph database have a natural advantage in understanding how these kind of different types of data and different tools relate to each other. So that might be something you look for. But when it comes down to it, essentially you want the tool to be able to help you to look at that information, things like where's the secret used? Is it in test? Is it in production? How critical is the resource that it's being protected, which is almost analogous with like what type of secret is it, and take that into account as kind of one facet of prioritization. But also you need to understand exposure likelihood. How many people actually have access to this? Where in your SDLC is it? How strong is your concept of least privilege? How strong is your authentication? There are indicators from the settings of many of your different tools that can be useful for prioritization. So this helps you to go beyond things that are very simple, like just one or two of these criteria. Being able to take all of this into account in your tooling can help you to really focus your efforts on the most critical things. All right, so Julie, you want to tell us a little bit about workflows?
Yeah, so the second poll that we did, about 20% of respondents said that developer buy-in was an issue. And so one of the ways you can address that is through workflow integrations, right? So if you give developers the right feedback at the right time, where they live and breathe in their repos, you're going to be more likely to have them buy into eliminating this coding practice, right? So the image here on the right is a picture of GitHub, and here just a part of the merge request, there's been a scan for hard-coded secrets. It's telling the developer right then and there, like, hey, you have a problem. Here are some things you can do. And that ranges from either fixing the problem right off, or perhaps it's not actually a real secret and the developer can flag it so that this doesn't come up on later scans. But the big idea here is that you're going to get more developer buy-in if you can eliminate context switches and give them feedback before they've moved on to something else, right? If they come back 2 weeks later, they're going to be like, what do I know about this code? I know it's been so long. I'm on to my next newest, greatest feature. So the other thing it does by attacking it at this time is that it protects your main branch from any of these secrets, right? And if you can prevent it, you're going to be in a much better shape. And then there's some workflow integration suggestions. So like doing pre-commit hooks, pull request integrations, alerting, ticketing system integration. So say you don't want to block the build, you can then open up a ticket request in Jira and then have, that secret will eventually be dealt with. And then finally, you need a way to confirm that the fixes have been successful. And so new scans need to show that you fixed the issue. And again, that's all about cutting down on noise.
Cool. Yeah. So the last kind of major capability that you're going to need is secrets management in order to get towards the top of our maturity model. Now, I want to be very clear. SiteCode does lots of things. This is not one of them. We do not have a secrets management tool. This is just best practice. So if you need a secrets management tool, you can get them from many vendors. There's the infrastructure players. Some of them, like Amazon and Google, offer a secrets manager. Vault is by HashiCorp is a great secrets manager. There are also tools from adjacent spaces. So CyberArk, which is in the PAM space, has a secrets manager. And there are standalone players like Achilles that offer them. And again, just the idea is it provides an alternative to hard-coded secrets by essentially coding your app to go reach out to the secrets manager when it needs access to something and getting a secret it can use. So really good best practice, and it's definitely complementary with the idea of hard-coded secrets scanning. In summary, we've talked about a lot of stuff today. We talked about why secrets are a large and growing problem, and that is essentially because of architectural changes in how we code these days, using things like microservice architecture, which have more authentication needs than we had in the past. We talked about how you can use a maturity model to drive the maturity of your program and kind of outline a practical path forward to developing an effective program. We talked about how an effective program needs tools that have specific capabilities, and 4 main areas are the ability to scan, the ability to prioritize the results from those scans, the ability to bake those scans into developer workflows so that you can, essentially prevent the practice from going forward, and the need for a secrets management tool as an alternative for developers. And then to get to the highest level of our pyramid, to risk reduction, you need to be thinking more broadly about secrets from the lens of your entire SDLC security or your entire security program. And that's implementing things like strong security and governance through things like authentication and the concept of least privilege, which will help to reduce exposure from compromised insiders and malicious insiders, respectively. And then the idea of dealing with code leaks by securing or at least configuring your environment such that it's hard for accidental leaks to happen, and then to use scanning solutions that fingerprint your proprietary code and look out in the outside world for your code so you can be notified if you do have a leak and take it down quickly. And what that's going to do is essentially reduce the time it's out in the wild and reduce the likelihood an attacker gets access to it. One last slide before we go into Q&A is just, what does SiteCode do? We'll keep it super brief, but we are a complete software supply chain security solution. We offer visibility, security and governance, and code integrity across your entire SDLC. That breaks down into a bunch of different use cases, including security and governance for your CI/CD, code tampering prevention, hard-coded secrets detection, which is germane to today's conversation, code leakage.
Definitely.
Absolutely. IAC security, software composition analysis, and compliance and security assurance. So those are kind of the areas we focus. With that said, head over to the Q&A tab, and we will do our best to go through the questions that have come in. So I'm going to pop out this little panel, and we'll start answering questions. So first question, Julie, how about you answer this one? Who owns the hard-coded secrets problem?
Everyone. My mother, no, maybe not my mother, but yeah, everyone. I don't mean to be glib, but I think development and engineering, they own the code. Security obviously owns it because it's a security issue. DevOps owns a lot of the tooling. So I think it's one of those things that you all need to come together to address. Again, it's a big picture problem, right? So really everybody owns a piece of it, and you have to work collaboratively. And that's not always easy, but I think if you have the right tool, it's something that you can definitely achieve. And again, secrets are really a hot commodity, so you need to be on top of it. So my short answer after my long answer is everyone.
Nice. Okay, so I'll take this one. The question is, what tooling do you see being used out there with regard to scanning for secrets in repositories? Okay, so there are many approaches to this. You can roll your own. There are open source tools like TruffleHog. You can get some amount of secret scanning from some of the SCMs if you buy their advanced security services. So like things like GitHub Advanced Security and GitLab Advanced Security. You do have to pay for that. And then, obviously there's tools like SiteCode. I would say one of the things that you really need to pay attention to is where can they scan? Many of the solutions out there are laser focused on SCMs. So, for example, GitHub scans GitHub, right? Like if you want to deal with this problem effectively, you need to be thinking more broadly, in containers, in S3 buckets, in I don't know, your build logs, that you need to be looking more broadly. But there are a number of tools out there, and you can get them from a number of sources. I guess that answers this other question. Do you really need to scan outside of your repos? So just answered that. So I'm going to mark that one. Can SAST testing tools discover code secrets in your code? Is there a value add for SiteCode? So that's a great question. I think I kind of just touched on that. So there are SAST vendors that do some amount of this as well. So I think the answer is that's another source of tool you can use. But there is a SiteCode value add, and some of it comes down to what I just said about scanning more broadly. And I think another value add is that SiteCode tackles a number of different use cases, like we saw on the last slide, and they can help to address some of the adjacent issues, things like code leakage and security and governance that help from a risk reduction point of view. Also, SiteCode can see very broadly across your SDLC and can bring in information that exists outside of just the coding phase, which you get with your SaaS tool. And that can help for prioritization and for remediation for that matter. So SAST is an option. I would say that there's a lot that can be done outside of the world of SAST to address this problem. Okay. Okay. We use HashiCorp Vault. Do we really need to scan for secrets? I think we covered that, but Julie, you want to hit that real quick?
Yeah, I think just to again, like GitHub Advanced Security, it's just looking at the SCM, right? Or it's not scanning. It's managing your secrets, but it's not scanning your whole SDLC. So you need to manage your secrets, but you also need to scan.
Yeah, absolutely. It's a 1-2 punch, right? It's like on one hand, you provide an alternative, which is the HashiCorp Vault, and on the other hand, you need to scan to make sure it's not happening. Otherwise, people could just not use Vault.
Yeah, and you also need to don't forget about those logs, right? That you might have. You mentioned this early on, but you might have a secret that's been burned or just in your logs, and so you need to really look at the big picture and find all your secrets as well as manage them.
Yep. Very good. Julie, I don't know if you have thoughts on this. Otherwise, well, actually, I guess it was my section, so I can answer it. Where do you think most organizations are on the secrets management maturity model? And Julie, keep me honest on this, but I would say like probably around a 2 or a 3. So basic detection, or maybe some of them are moving into more broadly advanced detection. You can kind of see that from some of the poll responses. People were very concerned about basic scanning. There were some people that were very interested in implementing or getting developer buy-in, which would be a sign that they were like up in a level 4 where they're starting to do enforcement and starting to do a secrets management tool. But I would say like a 2 or a 3 is pretty common.
Yeah, just to add on to that, I'm looking at the poll results, and nearly 40% said basic secrets or no secrets, like they're just getting started. So I think that's a good argument for people hovering around that too. Like we know it's a problem, and we're starting to do things about it.
Okay. What does governance mean to you? That's a word that's thrown around a lot. So great question. What I'm talking about with security and governance is it's the idea of, implementing consistent security controls and configurations across your tooling. So it's the idea of making sure that your source control management system, your container registries, your build tools, your cloud providers are locked down the best way they can with things like proper multi-factor authentication, branch protection rules, least privilege, security build rules, and making sure that they're configured in the best way to make sure that you don't have things like code leaks. So it's about configuration and security controls to me, as I've been using it. Let's see. What is SiteCode's deployment architecture? Like, is it, e.g., for example, is it agent-based? SiteCode is not agent-based. SiteCode uses a bunch of API integrations to basically integrate with all of the different tools that make up your software delivery pipelines. So it's essentially using an API to reach out to your source control management systems, and then essentially performing the scans. From there, gets up and running in minutes, no agents, so very easy to get running. I think we got all of them, or at least the ones that, as far as I can tell, I think we've got all the unique questions. So, thank you. And Cody, I guess back over to you.
Well, Orion, Julie, thank you both so much for joining us today. Really appreciate the conversations that we have before we go on the air, but also all the content that you guys share with us. It's always really informative, and I really appreciate the time.
Yeah,
So
great.
Our pleasure.
I'd like to remind our audience that this session was recorded. So following this panel, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. So those 4 $25 Amazon gift cards that we need to give away, our 4 winners are Stephen I, Dilip A, Anthony O, and Jen A. So congratulations to the 4 of you. Please keep an eye on your inbox to claim your gift card, but if you don't happen to see that email, please check your spam folder. I'd like to thank SiteCode for sponsoring today's webinar, and of course to our audience. We really appreciate you spending time with us today. We ask for one extra moment of your time to fill out a brief post-webinar survey that will pop up on your screen here in just a moment, but otherwise we do hope to see you at an upcoming Techstrong Learning program. Everyone have a great rest of your day.